Connective tissue is one of the four basic tissues of the body. General characteristics. Connective tissue is mesenchymal in origin. It contains large amount of extracellular substance or matrix, so its cells are widely separated. Some types of connective tissue are penetrated by blood vessels, lymphatics, and nerves. Connective tissue consists of cells, both fixed and wandering cells, fibers, collagen, elastic, and reticular fibers embedded in an amorphous ground substance or matrix material. Matrix material or ground substance is an amorphous extracellular substance made of a complex mixture of glycosaminoglycans and structural glycoproteins. Glycosaminoglycans, or sometimes called acid mucopolysaccharides, are formed by repeating of disaccharide units always contain hexosamine. Hyaluronic acid is one of the chief examples of glycosaminoglycans present in loose connective tissue. Also, hyaluronic acid and chondroitin sulfate are mainly present in cartilages and bones. Other types of glycosaminoglycans are dermatan sulfate and other sulfated saccharides. Structural glycoproteins are other component of the ground substance. They are formed by conjugation of protein and carbohydrates. They are adhesive glycoproteins that function to link cell membranes of various cells together or to the elements comprising the extracellular matrix. For example, chondronectin in cartilage mediates adhesion between cells, chondrocytes, to collagen fibers of the matrix. Fibronectin in basal lamina mediates adhesion between cells and between the cells and substrates in the matrix. Laminin in the basal lamina attaches the epithelial cells to collagen fibers of the underlying connective tissue. Types or classification of connective tissue. There are two main groups of connective tissue according to the nature of the matrix, general and special, from which further subdivisions are made. General connective tissues are distinguished as loose or dense, according to whether the fibers are loosely or tightly packed. Loose connective tissue can be further subdivided according to some special properties of cells, fibers, and matrix. Dense connective tissues can be divided into dense regular or dense irregular, according to the arrangement of fiber bundles. Special connective tissues include cartilage, bone, blood, and hemopoietic tissues. Functions of connective tissue proper. General function: support and connection of the various tissues and organs of the body. Functions provided by the various components of connective tissue. The cells provide healing of the injured tissues, produce heparin, histamine, and antibodies, store fat and preserve body temperature, and protect against microorganisms. The fibers provide rigidity or elasticity. Nutrition to the surrounding structures provided by blood vessels traversing the matrix. Cells of connective tissue proper are two types, fixed and wandering. We have to discuss the shape of the cell, the structure of the nucleus and cytoplasm, and the possible functions. Fixed cells are stable, long-lived cells present in most types of connective tissue, and most of them are branched. Fibroblasts and fibrocytes. Fibroblasts are the most common type, found in nearly all types of connective tissue proper. They are flat, branched cells, spindle-shaped inside view. The nucleus is large, pale, and oval. The cytoplasm is scanty, basophilic granular, with well-developed Golgi body, rough endoplasmic reticulum, and many ribosomes. Fibrocytes, on the other hand, are all less active fibroblasts with dark nuclei and acidophilic cytoplasm. Myofibroblasts are a special form of fibroblasts that contain actin and myosin microfilaments, like smooth muscles. They are found ordinarily in small numbers, but increase after injury. They produce collagen caused by their contractility, retraction, and shrinkage of the scar tissue, causing wound closure. Functions of these cells: secretion of collagenous, reticular, and elastic fibers, secretion of the ground substance, healing of the connective tissue after injury. Undifferentiated mesenchymal cells. They are similar to fibroblasts but smaller and are found in the embryonic connective tissue. Functions of undifferentiated mesenchymal cells. They can differentiate to give the other types of connective tissue cells. In the bone marrow, however, they give origin to the various blood elements. Reticular cells are similar to mesenchymal cells, but having long processes. Functions: they, together with the reticular fibers, form the stroma of the various organs. Pericytes or perivascular cells. These are similar to fibroblasts, but smaller, and located along blood capillaries. Functions: they have the pluripotential role of mesenchymal cells. They can give rise to other types of connective tissue cells when needed. Endothelial cells are simple squamous epithelial cells but mesodermal in origin. Functions: they can produce a special type of collagen and basal lamina. Fat cells or adipocytes are large, spherical, about 120 micron in diameter, abundant in adipose connective tissue. There are two types of adipocytes, unilocular and multilocular, that have different structures, color, locations, and functions. Cells of unilocular type have only one large fat droplet. The cytoplasm forms a thin film around it. The nucleus is peripheral and flattened. Fat needs a special stain to be seen, like Sudan 3 or Sudan black. In hematoxylin and eosin preparations, fat dissolves, so the cells appear as a thin ring of cytoplasm having a flattened nucleus surrounding large vacuole, signet ring appearance. The color of unilocular adipose tissue varies from white to yellow. Functions: unilocular adipocytes act as a storage depot for fat that can be used for energy production at time of need. They provide an insulating layer to preserve body heat. They support soft organs and form shock-absorbing beds in hands and feet. They give the body its smooth curves, especially in females. Cells of multilocular type show, on the other hand, round nuclei, and the cytoplasm contains many fat droplets and abundant mitochondria. Fat is stained orange with Sudan 3 or black with Sudan black. Functions: multilocular adipocytes produce heat toward the body on exposure to cold. Histiocytes or plasmatocytes or fixed macrophages. They are more abundant in loose connective tissue, having irregular shape and small darkly stained nucleus. The cytoplasm is rich in lysosomes and phagocytosed particles which can be stained vitally with trypan blue or neutral red. Functions. They are part of macrophage system of mononuclear phagocytes derived from monocytes. They are phagocytic cells protecting the connective tissue from invading microorganisms and play a role in acute inflammation. They can coalesce together to form foreign body giant cells to engulf large microorganisms. Wandering cells. They are wandering motile cells. Most of them may be short-lived and non-branched. Mast cells are oval or rounded in shape, abundant in loose connective tissue along the blood vessels. The nucleus is central and rounded. The cytoplasm is basophilic, granular, containing secretory granules, and possesses a poorly developed endoplasmic reticulum. The granules are metachromatically stained by toluidine blue because of their content of mucopolysaccharides, that is, glycosaminoglycans. Functions. Mast cells are concerned with the secretion of heparin, anticoagulant, histamine, which initiates allergic reactions, attraction of eosinophils to sites of allergy. They are also involved in acute inflammation. Leukocytes. The most common are neutrophils and eosinophils from granulocytes and lymphocytes and monocytes from agranulocytes. Neutrophils are spherical cells. Each has one segmented or lobulated nucleus formed of 1 to 5 lobes connected together by thin chromatin threads, and the cytoplasm contains numerous fine neutrophilic granules. Eosinophils, on the other hand, are also spherical cells. Each has a horseshoe-shaped nucleus or bilobed nucleus consisting of 2 lobes connected together by a thick chromatin thread. The cytoplasm contains numerous coarse acidophilic granules. Lymphocytes are spherical cells. Each has a large rounded, darkly stained nucleus and scanty basophilic non-granular cytoplasm. Monocytes are also spherical cells. Each has a large eccentric kidney-shaped nucleus and basophilic non-granular cytoplasm. Functions. All types of leukocytes are related to defense mechanism and immunity. Pigment cells or chromatophores or melanophores. They are small branched cells abundant in the connective tissue of the skin. The nucleus is small and dark. The cytoplasm is rich in melanin pigment. Function. Storage of melanin, which protects against ultraviolet rays of the sun. Plasma cells develop from P lymphocytes. They are oval in shape, abundant in lymphoid tissues. The nucleus is eccentric with a curved wheel or clock face appearance. The cytoplasm is basophilic, non-granular, rich in all features of protein sensitizing cells, that is, rough endoplasmic reticulum, well-developed Golgi apparatus, mitochondria. Functions. Plasma cells are concerned with the secretion of antibodies, that is, humoral immunity. Free macrophages are wandering cells derived from blood monocytes which enter the connective tissue. They are branched cells with oval eccentric nuclei. Functions. They are phagocytic cells that participate in the immunological responses. Fibers of connective tissue proper. Comparison between white collagenous, yellow elastic, and reticular fibers. Shape. White collagenous fibers, when present singly, are colorless, but on condensation they are white. They are arranged in bundles formed of parallel fibrils. The bundles branch, but the fibrils do not branch. On the other hand, yellow elastic fibers appear as thin branching fibers, yellow on condensation. They can be stained brown by urcine and yellow by vanchism. Reticular fibers are very fine, form a delicate network, and can be demonstrated by silver stain. They are stained brown by silver, and they are azurophilic, that is, they like the silver stain. Structure. White collagenous fibers are made of protein molecules called tropocollagen and possesses cross striations under electron microscope due to overlapping of tropocollagen molecules and precipitation of heavy metals in this region. Collagen fibers are classified into 5 types according to the chain of amino acids in it. Type 1 is found in bone and tendons. Type 2 is found in cartilage. Type 3 constitutes the reticular fibers. Type 4 is found in basal lamina. Type 5 is found in fetal membranes and blood vessels. Yellow elastic fibers are made of elastin protein formed by fibroblasts and smooth muscle cells in blood vessels. Reticular fibers are made of type 3 collagen. Special characters. White collagenous fibers are affected by boiling, enzymes, acids, and alkalis. On the other hand, yellow elastic fibers resist acids and alkalis, but are hydrolyzed and digested by enzyme elastase. Reticular fibers are made of type 3 collagen. Therefore, they are affected by boiling, enzymes, acids, and alkalis. Functions. White collagenous fibers give the tissues strength and rigidity. On the other hand, yellow elastic fibers provide the tissues with the power of stretch and elasticity. Reticular fibers form the stroma of organs like liver, lymph nodes, and spleen. Embryonic or mesenchymal connective tissue. Structure. It is composed of star-shaped mesenchymal cells having the power to differentiate to give the other types of connective tissue cells. The undifferentiated mesenchymal cells are embedded in an amorphous ground substance containing few reticular fibers. Sites. Embryonic connective tissue is found between the developing organs of the embryo. Mucoid connective tissue or Wharton's jelly. Structure. Mucoid connective tissue consists of undifferentiated mesenchymal cells, fibroblasts, and thin collagenous fibers embedded in a large amount of ground substance. Sites. Mucoid connective tissue is present in umbilical cord, vitreous humor of the eye, pulp of growing teeth. Loose connective tissue possesses relatively less fibers but more cells and extracellular matrix. Subtypes of loose connective tissue. Loose or areolar connective tissue. Structure. It is the most common type of connective tissue. It is a loose type that contains potential cavities or areola which can accommodate large amounts of fluids or gases. It contains all types of fibers and cells. Most common cells are fibrocytes, histiocytes, and mast cells. Sites. Loose areolar connective tissue is found everywhere in the body except in the central nervous system, connecting all organs and tissues together. It forms adventitia of organs, submucosa of gastrointestinal tract, and serous membranes. Reticular connective tissue. Structure. Reticular connective tissue is formed of a network of reticular cells and reticular fibers. The cells are similar to undifferentiated mesenchymal cells, and they can differentiate to phagocytic cells and also are concerned with the production and maintenance of reticular fibers. The fibers are algiophilic, stained by silver. Sites. Reticular connective tissue forms the stroma of all organs and glands, like bone marrow, lymph node, spleen, liver, and suprarenal gland. Adipose connective tissue is a loose connective tissue in which fat cells predominate. It consists of groups of fat cells separated by fibrous septae. There are two types of adipose connective tissue: white or unilocular type and brown or multilocular type. Comparison between the two types of adipose connective tissue: white or unilocular adipose connective tissue and brown or multilocular adipose connective tissue. Structures. In white adipose tissue, fat cells have only one large lipid droplet. The nucleus is peripheral and flattened. The color varies from white to yellow. It is highly vascular, but blood vessels are not always apparent. In brown adipose connective tissue, fat cells have multiple lipid droplets. The nucleus is round. The color is brown due to high content of cytochrome enzymes present in mitochondria. It is richly vascularized, more vascular than white fat. Sites. White adipose connective tissue is present in the mammary gland, subcutaneous tissue, renal bed of fat around the kidney, and in the mesenteries, while brown adipose connective tissue is commonly found in hibernating animals and newborn, around the thoracic aorta, and in the interscapular and inguinal regions. Functions. There are several functions for white adipose connective tissue: storage of fat, insulation of heat, support of soft organs like the kidney, gives the body its smooth contour, especially in females. It forms shock-absorbing pads in hands and feet, while brown adipose connective tissue is always concerned with release of heat. On exposure to cold, it releases heat to warm the body. Dense connective tissue contains more fibers but fewer matrices and fewer cells compared to the loose connective tissue. There are two subtypes of dense connective tissue, dense regular and dense irregular. White fibrous connective tissue. Structure. It consists of collagenous fibers and fibrocytes in little amount of ground substance. Sites. It is present in tendons and cornea. Fibrocytes in tendon are called tendon cells, while those of the cornea are called corneal corpuscles. Dense irregular connective tissue. Structure. It consists of collagenous fibers and fibrocytes in small amount of matrix, similar to the regular type, but the fibers are arranged in woven bundles, not parallel bundles. Sites. It is found in the sclera of eye and ligaments, in the periosteum, perichondrium, dermis of the skin, reticular layer, and capsules of organs. Yellow elastic connective tissue. Structure. It consists of predominant of elastic fibers with fibrocytes in little amount of ground substance. Sites. It is found in aorta and large blood vessels, trachea and bronchi, ligamentum nuchae and ligamentum flavum.